So now let us look at how we can use the digital multimeter to test an AC voltage. So when you are carrying out AC voltage test, that is a live test, okay? Which means that you need to take the necessary precaution. Know that you are working on a live circuit. The required PPE, you need to put them on. Your gloves, that is that can withstand the voltage environment that you are working with. You will be on your insulation mat. Then your safety shoe should be of the rated capacity, as in voltage withstand level. Okay, so now the circuit is live. That is what you are seeing on your screen now on the right. So the digital multimeter, when you want to use it to test for voltage, that is the digital multimeter you have on the screen now. Okay, so for you to test for voltage, the first thing you will do is to switch this selector switch, take it to the voltage range or section of your digital multimeter, okay, because it is AC voltage that you want to test. So the first thing you do is to switch the knob to the AC voltage, as you can see. Okay, so it is now on AC voltage, and that will also display here as showing that the range that you are in is the AC voltage range. Okay, now these are the probes connected to the digital multimeter. So what do you do when you want to test for voltage? First, you move your probe to the neutral line, assuming you want to test the live line to neutral, the voltage that is on line to neutral. So first you move your black probe, okay, to your neutral line. Then you take your red probe to test the line one after the other at the points that you can access. So here we can access the input to the circuit breaker in that particular circuit. So you take it line that is neutral to line 1, that is the red phase. Okay, so in our system here that we use 415 volt phase to phase, the phase to neutral, you have about 220 volts. 220 volts. Okay, so when you sorry that the meter, this digital meter is not this on-screen meter is not changing, but you will see that once the circuit is live, it will change to 220 volts. Then if it is a 215 face to face, a 240 face to face circuit that you are looking at, face to neutral will give you 120 or 110 volts. Okay, so on this you have the first line 1, you have 220 volts. So neutral to line 2, you also have 220 volts. Neutral to line 3, you also have 220 volts. So if the voltage, they are not the same on each of these phases, it means that we are having a problem. We are having a challenge. Okay? Now let us assume that the voltage is the same. That is, what it means is that we have input to our circuit breaker. Then next, we'll test the input to the circuit breaker that is feeding the control circuitry. Okay, so in these two, we are supposed to have the 220 volts. That is the low voltage that is we expect to go into the control circuit. Okay, then next, when you test the output of that particular circuit breaker, while the circuit breaker is closed, you have 220. Okay, so you switch the circuit breaker on and off to be sure that the circuit breaker is working. When you put it off, what you have will be 0 volts. When you put it on, what you have should be 220 volts. So if you are not having that, it means that that circuit breaker is faulty. Remember, what we are doing is testing the AC circuit. Okay, so let's assume that the output from that circuit breaker is fine. Okay, now to the next test that you want to do will be face to face. So you take the black probe to the other face, and then the red probe to line 1. So line 1 and line 2, which is a face to face, is supposed to give you 415 volts. Okay, so now remember that what you are doing now is testing the output of that circuit breaker. So when the circuit breaker is closed, you expect to have that 415 volts at that output. So also it is too when you test between the line 1 and line 3, line 2 and line 3. Okay, so you are supposed to have that 415 volts. So if you are not having that 415 volts, your contactor, if you are having, your input is correct. Okay, your contactor is your circuit breaker is faulty. The circuit breaker that is feeding the electric motor, as you can see. Okay, so it's faulty. That is what it means. So now, for you to test the other components in the circuit, remember we are testing live. You will come down to the contactor. These are the various terminals. Okay, line 1, line 2, line 3. You are supposed to have 415 volts. So once you have that voltage signal at this input terminal to your contactor, that confirms that everything above the contactor is good. The line connecting the contactor and the circuit breaker, the line connecting the circuit breaker and your bus or your input line, okay, to the circuitry, they are good. The contactor above, the circuit breaker above the contactor is also good. So next, what you do is you can close it. If you want to work without the control circuit, you can manually close the contactor. But while you are closing the contactor, if it is safe to do so, you can close, because you know when you close, since the circuit breaker is closed, you are closing power to your electric motor. Your electric motor will start running. Okay, but if it is safe to do so, you can close. But if it is not safe to do so, you go to your motor end and disconnect the terminals, okay, and make it safe so that they don't breach. So whichever that is convenient for your situation, that is what you will adopt. Then you close the circuit, the contactor now, and then test the line, okay, between the phases. When you get output of 415 volts between line 1, line 2, line 3, line 4, line 1, line 3, okay, you will see that you can confirm that the contactor is okay. Okay, so if it is not giving you an output, then it means something is wrong with that contactor. So you carry out further troubleshooting to ascertain ascertain whether the contactor is working or not, or the problem that is with the contactor. Okay, so that is for the power circuit. Now, if you look to the right, you will see that we also have a control circuit. The malfunctioning of the control circuit that is powered by AC can also disrupt the operations of your electric motor. So now, remember, we have tested to the output of this circuit breaker feeding this control circuit. let's assume that this one is okay. Then to the input to your stop button, okay, if you test, if it is okay, it means that we have power to this your stop button. So remember, the stop button is a normally closed push button. Normally closed push button. Okay. So what you do is, well, what is sure is that since it is normally closed, you are supposed to have voltage signal at the other end, the output of that normally closed push button. Okay, which means that at the input to your start button, which is a normally open push button, we have voltage signal. So if you do not have an output from this normally closed stop push button, it shows that this push button is bad. Okay, or there is a problem with it. It's possible that there are build-ups, debris, okay, on the contact. Increased resistance can also insulate the contact. Okay, so you can zero in on the stop push button for further checks to ascertain what is actually wrong with the push button. So next is the start push button. When you depress it, of course you expect that the output of it should have signal. If there is none, that means that the start push button is faulty. Okay, and when you release, you are supposed not to have an output on the other end. Are you getting it? Because it is a normally open push button. So when you release, the contact is expected to open back. If you are not familiar with the switch operations and their symbology, check out our training on electrical diagrams. Okay, electrical diagrams and electrical component symbols, they are treated in that particular training. So now you will see that the output from this control circuit is feeding the contactor coil. Look at this end of the contactor coil. Okay, is to one this end of the neutral from your power supply is to one end of the contactor coil, while the output from your control is to the other end of the contactor coil. So when this is closed, power will be sent to your contactor coil, and it's expected that the coil will be energized, and that will close the contactor, and that of course will close power to your electric motor. So if the circuit is functioning normally like that, that clearly tells you that the problem is not with your circuitry, both control and the power circuit. So you can now go to your electric motor for further tests. So we'll see later in this program how you can carry out tests on electric motors.